Algebra 2, Lesson 17. We're going to talk about solving equations and inequalities with absolute value. This picks up in your book on page 116, in case you're interested. I've seen this show up with students in other classes. I'm not sure if this class has had a problem with it. I think more so maybe geometry. Geometry deals a little bit more with length and distance and area and things that have to have an absolute value. An absolute value is the absolute value of a number is the distance along the x-axis from the origin to the graph of the number itself. Now, the reason absolute value is important is because there are certain things in life that are never negative, right? The things that you can't get negatives on. What kinds of things are never negative? Area is never negative, right? You never have, yeah, you can lose a lot of weight. You're never going to weigh negative pounds, right? Okay, you can't make something a negative weight. What else can't be negative? Okay, area, or what do you say? Well, you said area, though, all right? We could also say weight, okay? Even if you were weightless and you were out in outer space somehow and you know, no weight, right? At most, you would be what? 0, right? Your weight would zero out. But you're not going to be negative. Does that make sense? All right, what else? Mass is never negative, right? Mass and weight are two different things. What about length? Distance. Is distance ever negative? Right, and that's important. Distance never being negative is important in what we're going to look at today, because what this definition is talking about is the distance a number is on the x-axis from the origin or from 0. All right, so can we get negative numbers on a number line? Yeah. Okay, but when we're talking about their absolute value, we're not talking about their value, we're talking about distance. Okay, and that's an important thing to understand. Okay, and hopefully I can make this make sense. All right, so here, granted, as I was looking at trying to turn your book into notes, some things are really hard to do. For instance, drawing a number line is not an easy thing to do. So what I did is I went ahead and I just put up a dotted line, and I was like, well, I'll just make the number line as we go. So for instance, if x is greater than 0, the absolute value of x is x, right? Absolute value is always positive. Even if there's a negative number inside the absolute value bars, when I drop the absolute value bars, the number becomes positive. Okay? So the absolute value of 7 is 7. For instance, if, let's say my origin is here, okay, and we count 1, 2, 3, 4, 5, 6, 7, right? Here's 7, right? The absolute value of 7 is 7. So 7 is the distance. That makes sense. We deal with positive numbers really well. It's whenever we get into the negative numbers that we kind of start to have a problem. If x equals 0, then the absolute value of x is still x, meaning that if, let's say we're at here for 0, and we're on the line. There it is right there. Okay, well the absolute value of 0 is 0. There's no negative 0. Okay, 0 is just 0. Okay, and if we go on to the negative side, okay, we've got 0 right here, negative 1, negative 2, negative 3, negative 4, negative 5, negative 6, negative 7. The distance, absolute value of negative 7, is 7. And I think it's a little confusing how they put that, because they have like a negative parentheses, negative 7 close parentheses equals 7. I don't know that that's quite necessary to have in there without it just being confusing. But the absolute value of negative x is x. So if x is less than 0, that makes it a negative number. That's what you're seeing right here. Okay? If x is less than 0, then the absolute value of negative x is x. So the absolute value of negative 7 is 7. That should be fairly easy. Do we have any questions about that? Okay. We are going to find, because we're talking about absolute value, and absolute values have to be positive, we do have extraneous solutions. To solve absolute value equations, this is what makes solving absolute value a little bit different. Okay. We use inverse operations to isolate the absolute value expression on one side of the equation, then consider two cases. So rule number one in solving for absolute value, make sure that you get this. Rule number one, isolate the absolute value. Okay? And that becomes important because sometimes I can have something outside the absolute value. Let's say, for instance, I'll erase this in a second. I have -7 plus 9. Okay, I've got that absolute value plus 3 equals 15. Okay, before I can begin to solve that, I have to move the 3 over to the other side. Okay, so I would get, I could go ahead and I could probably finish this out inside here where I'm getting 2, but I need to know that this is going to be 12, right? Now, granted, I'm just making something up here, so I know that 2 doesn't equal 12, but you see what I'm saying? We could probably have made this x, x and x here and gotten 2x, and right when we pulled that out, we would get, 2x equals 12. But here's the next thing that you need to understand is that we're going to solve two cases. Not only are we going to say 2x equals 12, but we're going to say 2x equals -12. Okay? The reason being is because with a variable in there, okay, -12 equals 12, right, in an absolute value situation, and so does 12 equal 12 in an absolute value situation. So there's always two possibilities with absolute value. There's the negative and there's the positive. So whenever I go to solve it, right, I take what's in the absolute value already and I set it equal to the positive solution, and then I set it equal to the negative solution. So the two possibilities for this equation that I've just made up are 6 and -6, because 2 times 6 is 6, or sorry, 2 times 6 is 12, and 2 times -6 is -12, but whenever I drop the absolute value, I get 12 both times, right? Do we understand that a little bit? Okay. All right, we'll see a little bit more of that as we go. Like I said, I just made that up off the top of my head, so I don't want you to get confused by the eccentricities of it. So here they give you a situation. If the absolute value of x minus a equals k, then x minus a does equal k, or, and I need to do this too, x minus a equals -k. So I need to set it equal to the opposite solution. So in here, all they do, if I was trying to solve for x, and this x equals a minus k, all they did was they added a to the other side. Okay, so you can see where they added, add a here. So x equals a minus k. Okay, that's what they're getting here, right? Or, if I look at this one, I'm adding a, x equals a plus k. I kind of wish that they would have done those in different orders, but if I was trying to solve for x, I could have done that. Does that make sense? Okay, I can slow down. Did I go too fast? No. Okay. All right. So extraneous solutions. Extraneous solutions are solutions that, although we might get them, whenever I go to plug them back in, they no longer work. Okay, it's an extraneous solution. Two equations above are derived or obtained from the original absolute value equation. Derived equations may result in some extraneous solutions. These solutions do not satisfy the original absolute value equation. Therefore, you need to check all possible solutions, which means whenever I plug it back in, it doesn't work. Okay. All right, let's see if there's anything else in here. Oh, there is. Absolute value inequalities. Absolute value inequalities can be solved by rewriting and solving as compound inequalities. Absolute value inequalities are either conjunctions or disjunctions. Well, let me just kind of draw this up here real quick. Conjunctions are where I have a line between 2 points. Okay, and it could be filled in over here and open over there, or both filled in or both open, or whatever combination of those two things. This would be a conjunction. Anybody in here ever, I don't know, whenever I see the word conjunction or hear it, I always think of Schoolhouse Rock. Anybody in here ever? How many of you think, okay, conjunction, junction? Okay. All right. So a disjunction, I'll show that down here. It could be open or closed, doesn't matter, but what I'm getting is arrows going away from each other. That is a disjunction. Okay? Conjunctions use the word and. Okay, disjunctions use the word or. It's this or that. Okay? Not together. If it's this and this, all right, that's where I'm filling everything in between. Okay, does that make some sense? Yes? Hopefully. All right, so I'm going to erase this for now, but just hopefully you'll remember that. Okay, we'll look at some instances. All right, so we've got x's. Well, let's go ahead and put some things on here so we actually know what we're talking about. Let's go 1, 2, 3. There's a 3. 1, 2, 3. That's a negative 3. So if x is less than or equal to 3, that means I'm going to put a closed-in circle there, right? Okay, and my arrow would naturally go to the left, correct? All right, and x is greater than or equal to negative 3. So I'm going to come over here. It's equal to, so I can put that, and it's greater than. So my line goes back and forth between those 2 points. That is a conjunction. Does that make sense? Okay, good. Down here, right, let's see, let's do 0. Let's do 1, 2, 3. 1, 2, 3, that's negative. All right, and just read it. X is greater than or equal to 3. All right? Closed circle goes to the right, correct? Greater than 3. All right, over here, x is less than or equal to, so fill it in. Negative 3, it's less than, so I'm going to go to the left. There's my disjunction. Okay, do we understand how to graph those? All right. No questions then, I guess. All right, conjunctions can be replaced with absolute value. Let's go ahead and actually write that correctly. Value statements of less than. Disjunctions can be replaced with absolute value statements of greater than if A is positive. Then the absolute value of x is less than A is the same as the conjunction x is less than A and x is greater than negative A. So that's what you want to be aware of, is that whenever we're talking about absolute value inequalities, remember how in that original one we said is equal to 12 or is equal to negative 12? Okay, so here, if I have the absolute value of x is less than A, then the other side of that means not only is x, let me do my thing. Okay. Is it not? Come on. There we go. There we go. So if I break this out, we're saying two things. We're saying x is less than A, but then we're going to say x is greater than negative A, because whenever I put that negative on my solution, I flip the sign. Okay, so I have to remember to flip the sign whenever I'm working with compound inequalities with absolute values. Okay, flip the sign on the second one. This one will always keep the sign the same way, but the second one will be negation and a flipped sign. Okay? All right, I think that gets the bulk of it. So if we look at this statement down here, note that the statements like the absolute value of x is less than negative 4 and the absolute value of x is greater than negative 4 are special cases. This first inequality doesn't have a solution. Why might this not have a solution? Think about it for a second. What do we know about all absolute values? They're positive. So is it possible for the absolute value of x to be less than a negative number? No. It's impossible. Therefore, it has no solution. Now, because we know that all absolute values are positive, whatever I plug in for x, is it going to be greater than negative 4? Yeah, so that's why on the second case I have all solutions. The same thing I want you to understand works not only for inequalities but for equalities. So like for instance, If I have x equals negative anything equals, let's say, negative b, this is no solution. There's no solution to that because I can't have an absolute value equal a negative number, right? I don't even have to solve it. I know if it's set, if I have an absolute value set equal to a negative number, it won't work. All right, so hopefully that's some stuff that'll help you. That's what we call extraneous solutions. All right, when you see a graph of an absolute value, this is what we call the parent function. That's the most basic form of this function, but that's an absolute value function. It's a function that contains an absolute value expression. The graph here is y equals the absolute value of x, or you could look at it as f of x because we're just subbing in f of x for y. It's going to be two-dimensional because there's two variables, x and y. If you look at it like this, if we got x and y, if I do, let's say, the absolute value of x, we say absolute value of negative 3. Well, the absolute value of negative 3 is 3. The absolute value of negative 2 is 2. The absolute value of negative 1 is 1. The absolute value of 0 is 0. The absolute value of 1 is 1. Right? So you see, here's my 0. I have 1 is 1, and negative 1 is 1. 2 is 2. Negative 2 is 2. So do you see how that graph is always going to come down to 0, and it's going to spread out? Okay? Now, that's based upon the parent function. We can take the whole thing, and we can do different things to it that'll move it to the left or right, up or down. Okay, but that's the parent function. We'll talk a second about parent functions. Maybe it's down here. Okay, here we go. So that graph is the parent function of an absolute value function. It does not go below the x-axis because y equals the absolute value of x. And the absolute value of a number is never negative. This you'll see in Algebra 3. So if you go on to that point, you'll see parent functions. We haven't gotten to it yet in Algebra 3, but we're fast approaching it. It is the simplest function of a particular type. So there are parent functions for different types of equations. New functions can be graphed by transformations or changes to the graph of the parent function. These changes can involve changes in size, shape, orientation, or position of that parent function. That's effectively it for this lesson. Let's go ahead and see if we can't pull up some questions that we can work out. Let's see, what is this, lesson 17? Okay. Do we feel like did we go too fast through that about right, or? Okay, all right. All right, so looking at this first one, all right, remember rule number 1. What was rule number 1? All right, so what do I do here, Angela, to isolate the absolute value? Subtract 5. All right, so as I rewrite that, I'm getting an absolute value of 6x minus 9 equals what?
Negative 3.
Okay. All right, what's next? Eric? No solution. Why? That's right. Very good. Saved us a lot of trouble because the next thing that we would have done is 6x minus 9 equals negative 3 and 6x minus 9 equals positive 3, right? But because this is set equal to negative 3 as it is, I'm never going to be able to plug anything for x that's going to get me negative 3. I can get 3, but I can't get negative 3. Okay? So no solution. Okay? All right, number 2, same rules apply. I need to do what first? Rule number 1. Add negative 6. Nope. Nope. We have to undo the operation that's happening, right? So imagine, you're looking at it, and I think the absolute value is throwing it off, but really what negative 6 is doing is no different than if it was this. In which case, what would you do with the negative 6? Distribute it? No. If I was trying to isolate the parentheses, what would I do? Divide, right? Because it's multiplication. So we are going to do what here? By negative 6 on both sides, right? So now I've got absolute value of 6 plus 3x equals what? Four. Negative 24 divided by negative 6 is 4. Now, is it no solution? No, because it's a positive number. So now I have to write two equations, correct? All right, what are my two equations? Okay, and? Okay, those two equations are equations I need to solve for x. Okay, so let's look at this first one. What's the first thing you would do with 6 plus 3x equals 4? Subtract 6. All right, so that would give me 3x equals what? Negative 2, and then what? Divide by 3, so x equals what? Negative 2/3. So I got x equals negative 2/3. Let's come over here. Then I've got 6 plus 3x equals negative 4. What am I going to do first? Okay, so I get 3x equals what? Negative 10. All right, now what? So x equals what? Negative 10 over 3. So my two answers are this and this. Do I see anything that matches those two things? B matches those. Okay, I get two answers. Notice that C does get the negative 2/3, but they don't do the whole second equation. That's my warning to you, is that most people that get these wrong forget to do the second equation. They forget to set it equal to the opposite solution and solve that one as well. Absolute value equations will always have two solutions. One of them might be extraneous, okay, but you should always end up with at least two possibilities, okay? Not at least two, okay, just two. Questions? No? Okay. All right, 3. What's the first thing you want to do? Add 9. Okay, here we've got an inequality. So we're adding 9. So I have x, absolute value of x minus 10 is less than what? What's negative 1 plus 9? 8. Very good. All right, Allison. I need to write two equations. Tell me what the first equation is. Very good. Okay. All right, let's look at x minus 10 is less than 8. Jewel, what would you do next to solve the first one? Add 10. Okay, I added 10. So I get x is less than what? 18. Okay, John, what would you do with the second one? All right, so x is greater than what? 2. Okay, so we should be able to write a compound, right? X is less than 18 and greater than 2. Okay, are these going to be open circles or closed circles? Open, they're going to occur at 2 and 18. Okay. Is it going to be a conjunction or a disjunction? Are they going to go together or away from each other? Conjunction, because, all right, I've got my open 18, I've got my open 2. It's less than 18, but it's greater than 2, so I'm looking like that right there. All right, let me hit pause on this and I'll answer the phone. All right, let's look at number 4. If my cursor will quit thinking. There we go. All right, we should be getting a little bit better at this. What's the first step in isolating the absolute value on number 4, though? Do I divide or do I subtract first? Subtract. Good. All right. What's interesting about moving things across the equal sign is it has the opposite order of operations. So you actually start with addition and subtraction, then you do multiplication and division, then you do exponents, then you do parentheses. So just so you're aware of that. I'm not sure if you've ever thought about that. All right, so the first thing you want to do is subtraction here, right? So you're getting 6 times the absolute value of 5x is less than or equal to what? 4. Okay, now what? Divide by 6. So the absolute value of 5x is less than or equal to, what's 4 divided by 6? Is that 2/3? 2/3. So now I need to write two equations, right, Axel? Can you tell me what those two equations are?
5x is less than or equal to 2/3.
That's the easy one. Okay.
5x is less than or equal to negative 2/3.
Mm, greater than or equal to negative 2/3. Okay. Now, what do I need to do with both of these? I'm not done yet because I haven't solved for x. What do you think, Danielle? Divide by 5. Okay? On both. Okay. Now, to kind of maybe simplify this in your head, 5 is a fraction over 1, right? Okay? So, in the end, I'm multiplying by the reciprocal because I can't divide by a fraction, correct? So that's 1 times 2, which is 2, and 5 times 3, which is 15. All right? Over here, okay, same story. Negative 2/15. So x is greater than or equal to negative 2/15, and it is less than or equal to 2/15. So what we should see looks like this or that. Okay? Questions, comments, concerns? See, you guys are typically out of here at what, 10:36? So if I stop right here, that gives you guys about 10 minutes to work and ask questions. So I will stop right there.